Hello students, Professor Benavides here. Let's talk about our chapter on classes and objects. This particular chapter gives you an overview of object-oriented programming. We'll discuss a lot of terminology at first, and then we'll get into some examples. So we'll talk about capitalization, inheritance, overloading, constructors, getters and setters, UML. So yes, a lot of terminology. So let's start off with that terminology. Hopefully it will become more meaningful to you as time goes on, and when you see it in code, it will click. So encapsulation, what is it? So encapsulation lets you create a class template for creating objects. It is the process of hiding the attributes of a class and making them accessible via the object's methods. A lot of words here. What are the ones to remember? Encapsulation means data hiding. In a nutshell, it means private data and public methods. Inheritance is, in a nutshell, is when you take advantage of something that's already been made. In this case, let's assume that we've got a superclass and a subclass. And like, for example, the superclass can be a plain car, and a subclass can be a sports car. So the sports car can inherit from the superclass and take advantage of all of the designs of that superclass without having to write all that code. Then we go on to talk about polymorphism and in overloading and overriding, which are a little bit more abstract concepts in object-oriented programming. So by using polymorphism, you can create a new object that performs the same methods as the base object, but which performs one or more of these functions in a different way. And actually, there's different forms of polymorphism. This is just one aspect of it. But we're going to go ahead and take a look at overloading and overriding. So overloading, we talked about that really already when we talked about methods. Remember when we talked about how the method signature, when it has a different number of parameters, you can go ahead and call that method, pass in it that particular number of parameters. It'll know which one to choose. So it's okay to use the same method name again, just as long as you have a different number of parameters. That's called overloading. Overriding is when you have, for example, in the subclass, remember that sports car, a method, say for example, create the motor, and you want to go ahead and have a faster motor. So what you're going to want to do is override the method in the superclass so that you can go ahead and use the behavior specific to the subclass. So those examples, of car and truck, we see them many times in inheritance. And as far as overriding is concerned, I think it'll be better that we go ahead and look at that in code. Overloading, like I said, we saw that already in the methods class or chapter, and we can see it in the kind of methods that we use in the Java API. Here we see that the author is showing us the show message dialog method. And we see here that it takes a different number of arguments. Have you ever noticed how when you type in JOption pane and you put in that period and you get a drop down and you've got a whole bunch of things there? Well, what are those? Well, those are all the overloaded method. It's the show message dialog that's overloaded. And it'll provide you with a different behavior depending upon the kinds of arguments or the number of arguments that you send it. So she goes and shows you this as a means of comparing, overloading as we see it in the API, and how we can then go ahead and use that same concept when we create our own methods. So here in the show message dialog method, we can see that this particular method is taking 1, 2, 3, 4 different arguments here. So you get different kinds of effects depending upon the number of of arguments that you send. And how will it know which one to choose? It'll know based upon the context. So if you send it 2, it'll go and use the one that has 2 parameters. If you send it 3 arguments or 4 arguments, it'll go ahead and use the definition that has 4. So that again is called overloading. So now that brings us to the class. A class defines a particular kind of object. The name of a class begins with a capital letter. You know, I think we've been talking about that really since the first chapter here. So objects, you must use a lowercase letter, and classes must begin with an uppercase letters, right? So just think of a class as a blueprint for an object, and an object is an instance of a class. Again, each class is a blueprint, and an object is an instance of that blueprint, okay? Again, remember, objects must begin with the lowercase letter. Those are our conventions. They're not, it won't be a syntax error if you don't, if you like, say, for example, create an object in all caps, it's not the Java way. I mean, programmers typically understand something that's in all caps to be a constant, not an object. So you're not going to be writing in a way that people are going to understand your code. You know, you've got to go ahead and buy in to the conventions. And the convention is just agreed upon way of coding. It's not a syntax error again, it is a convention. All right, so objects, as I said, begin with a lowercase letter. Here we see an example of creating an object. So cow is the class. Let's go ahead and say that someone already built the cow class, you know. Cow1 is an instance of cow. And that object is created by calling the new method. And in the parentheses, we will go ahead and pass the attributes to create that instance, all right? So I think we're going to need some more examples on that. But for right now, let's talk about setters and getters. Inside your class definition, you're going to have a variety of things. I mean, you're going to have your private data, your constructors, and your setter and getter methods, as well as any special methods that you're going to want that particular class to have. These setter and getter methods, we've already been using them. Like, say, for example, in Alice, we have procedures and we have functions, okay? So when we look at the procedures and functions tab, we look at the words and we see something like get distance. Well, get distance too, that is a function, okay? It's a function because it's going to return something, okay? It's getting the distance. So what is the syntax that we have to learn here? The syntax is object dot method, okay? Object dot method. In this particular case, shark dot get distance to pajama fish. What's happening here is we're passing pajama fish to the get distance to method that will calculate or give us the distance between the shark and the pajama fish, okay? So setters, on the other hand, are return statements, okay? And you know, so they will return something. You know, that's pretty much you know, what a setter is. So you'll see something like set rather than what? Rather than get. Very important words. The reason why it's important here is that we're going to copy this. When we write our code, we're going to use this same terminology. We're going to say, you know, get, you know, and set to distinguish between setters and getters. So a getter simply returns something, right? And a getter will return something. That's a return statement. And then a setter, okay, is an assignment statement. Again, a setter is an assignment statement. It will set something to a particular value. So here we see in Alice the procedures tab and the function tab. Notice again the words. In the procedure tab, we have setters, okay, which perform the assignment statement, and then functions. which you end up doing a return statement. Now, Java we can create setters and getters in Java as well. As we saw them in Alice, that happens in Java, as well. So we're going to use that same analogy. Now, one of the big reasons for using setters is to engage in data validation. That means that when we create an object, we're going to want to make sure that the numbers are within a particular range that makes sense. Like GPA should be between 0 and 4. The age of a person should be positive number, right? So, and you can do validations any way you want. I mean, let's say you know that the hourly rate at your company ranges between $10 and $20 an hour. Well, you can create a validation. Now, validation is typically done with if statements. So we'll perform a test, and if the test is if it's good, then we'll go ahead and allow for the assignment. So a lot of times when you're dealing with OOP, you will find that designers will use some kind of graphics program to help them visualize their algorithm. So something that's very popular today is UML. It stands for Unified Modeling Language. And in this particular example here, we're going to see a model of a college student. So if you'll notice here, let's look at this little graphic here. We see at the top we've got the class name, the class fields, which include the instance variables, and then the methods below. Those are the 3 little sections on here. So we create a college student class. Okay, this class can include any kind of fields that you want. I mean, you're the one that's going to define the attributes of a student. In this case, let's just go ahead and say name, GPA, and credit hours. And then we're going to have a constructor. A constructor goes by the same name of the class, and it will go ahead and it's going to be used to go ahead and create the object. So here we have college student. Notice how it's the same name as the class, and this is the first method on the list here. The other methods that we see here are setters and getters for each private data member. Okay. So continuing on this, we see that it's split into 3 sections. The top section represents the class name. The middle section represents the fields, the class fields. These are, in other words, the instance variables, the private data. And the bottom, and it's typically private, doesn't have to be private, but that's a definition of encapsulation. It's private data, public methods. The bottom section represents the class methods. So the fields and the methods are denoted with a plus or minus sign in front of them. The minus sign indicates that it is private. The plus sign indicates that it's public. And there's going to be a really good reason why you want to go ahead and have your data private, because we're buying into the concept of data hiding to protect it, so that the only way into modifying this data is by means of an interface, and that interface is the method, a public method. Okay. We could go ahead and just make the data public, but then you wouldn't be able to engage in any kind of validation. You wouldn't be able to test the GPA or the credit hours, nor would you be complying with one of the most important concepts in object-oriented programming, which is the encapsulation. Okay. So then we go ahead and that's pretty much the visual design on here. This code that we see here, I'm going to show you this in live code in just a minute. We'll just wait for that point in time. But basically, as you can see, that UML is being exhibited here in code. We've got our private data, our constructor. Now the constructor here is called when we instantiate an object, and we go ahead and see that it's calling the set methods and passing in a variable, okay, a parameter variable, right? So the setters and getters. So the setter, as we said, is an assignment statement, which assigns the variable to the private data member, right? And the setter is the getter methods will return the value. Okay, so we don't have any special methods in here, nor do I see any kind of validation. You'll say, well, why are we going through so much trouble? Why don't we just go ahead and make all the data public? But then if we did that, then we wouldn't be able to do validation. You're saying, well, you're not doing it here anyway, right? I don't see any ifs or anything like that. Well, this is the best design for future, for building upon this class in the future, so that later on you can go ahead and add validation to this. So typically, after you go ahead and design your class, you're going to go ahead and create the constructor. And actually, you really can't create the inside body of the constructor until you do all of your setters and getters, okay? So that's the class. That's the non-application. Now that brings us to the application class, or the client. So we have to create another file. Typically, both of these can be in the same file, but then that detracts from modularity. And we typically want to go ahead and reuse classes, and it makes more sense to go ahead and have one file, one class, than to have everything all in one file. So we typically will create our class first, and then we'll go ahead and instantiate the object based upon the class. So if you'll notice here, we have college student space student one. So college student is the class that was from the other file. Now, these two files need to be in the same folder, or for that matter, be in the same namespace, right? Or package, excuse me. The new keyword calls the constructor, and we pass it bill 3.755. So bill goes in the name, 3.7 goes into GPA, and 55 goes into the credit hours. We're not going to mutate the data or anything like that. We're simply going to go ahead and get it back with an S out, and this S out here, or system.out.println, is simply going to concatenate a string with the getter methods to go ahead and create the output seen here below. So we're gonna have three getter methods. We're not engaging in mutation of the data with setter methods, which we could, like say for example, we could update the GPA, we could update the credit hours, and things of that nature with say for example, student one dot set GPA. And then if we went ahead and printed out the data, we would see that it had indeed changed. Okay, so that's pretty much the end of this chapter. Let's go ahead and take a look at the summary. The summaries of these chapters are typically pretty good. They kind of like bring everything together for you. So you see here that this chapter covered some important OOP, object-oriented programming terminology. It made the distinction between overriding and overloading. It talked about setters and getters, and it finished off by talking about the Unified Modeling Language, UML, which is used to graphically represent fields and methods of a class. Okay, so let's go ahead and take a look at some code here. I've already typed in that the example that was in your book. I went ahead and typed it in here. I did embellish it a little bit. I mean, I put in some extra little spaces and stuff like that here and there. And I think I know I did do some minor data validation in the class so that we could go ahead and see it. So you typically got to start with the class first. That is college student. So let's look at college student first of all. So first of all, you'll notice that college student is in a package. This is about the only time that we're in this class going to be using a package is when we're going to be using OOP. You know, in the previous chapters, we've told you specifically, let's don't use packages. We don't need them. But in this particular case, it's a good way of putting everything in the same place. Okay, so we will be using a package statement. So here we have it. Here's our private data member, private data. We have our constructor, which calls the set name, set GPA. And if you use the this keyword, it allows you to access the methods with a drop down. That's helpful if you have like a lot of methods and you need to remember what they are. You know, you can go ahead and use it that way. So when you instantiate the object, it's going to go ahead and come here, and it's going to build is going to go in here, and 3.7 is going to go in here, and whatever the credit hours is going to go in there. And then those variables are going to be sent as arguments to these three methods. Here are the methods. Here we've got the set name, get name. No validation there. I did a little minor validation on the set GPA. Let's go ahead and say the GPA for this school is between 0 and 4. So if that's true, we'll go ahead and allow for the updating of the GPA. Else we'll go ahead and say, hey, you know, GPA is out of range. Go ahead and re-enter it between the range of 0 and 4. Set credit hours, again, I engaged in some very minor validation. I'm just going to go ahead and say, hey, you know, if it's a positive number, I'm going to go ahead and allow for this. But if you put in a negative number, in other words, I'm not allowing bad data in, and you know. So this is the whole reason that we're engaging in this scheme of calling setter methods inside of the constructor. Okay, so coming back over here to the client program again, this is the you know, non-application class, right? This is the service. This doesn't have main. Look at that, no main. Okay, so I mean, you can you know, there's no main on here. You can build it. So if you want, you can do you know, a clean and build, you know. But here is the main method in the other file. This is the one that we're going to go ahead and run. So it's right here on this line here, and I just put S1 instead of student 1, like in the book she called it student 1, you know, on here. So and let me go ahead and run it. So here I have it, build 3.7, and here's the output here down below. All right, so very good. If I wanted to go ahead and create another student and show that information, let me go ahead and copy this real fast and show you how fast I can go ahead and do this. Now let's just go ahead and call this student 2. All right. In this particular case. And you know, this will be let's say Mary, right? And she has a 3.0 and 155 hours. She's taking a lot of hours, right? In this particular case, we've got to change the name to student 1 or student 2, excuse me, right? I'm just abbreviating, which is probably really bad. It's kind of like don't do it like this, but you know. So here we got it. I probably want a little line separating them, so I'll just do a little S out here, right? So let me go ahead and run this and see what we got. So here we got build 3.755, and then we have Mary 3.0, 155 hours. So again, if you have time, I probably recommend that you go ahead and do the step into on this so that you can see how things work. A lot of students don't see how these two files are related. Maybe I should show you that. We're going to go ahead and go to, you know, run, and we're going to go ahead and well, let's go to debug and do the step into. And in this particular, I'm just going to be pressing F7, okay? So you see how it stops on this line? I'm going to press F7 again. Boom, look, where do I go? I go to the other file. All right, it goes to the constructor. And it's got build 3.755. And as I press F7, look what's going to go. And it's going to go ahead and call set name. And it goes to set name, and it sets it. Then it goes and calls set GPA. And it goes and does that. And then it goes and does the set credit hours, and it sets that as well. The else clause is not called because it's all you know, appropriate data, right? So then it goes to the blank line, and it goes to the second student, and it goes and does exactly the same thing, right? Until you continue to press F7 until the program terminates. Okay, so that's how you can use debugging. Is used to find errors. I'm using it here just to show you the flow of control. Right? If you want to learn more about using the debugger, we have an appendix at the end of the book that you can go ahead and consult. All right, so let's go ahead and test one of these to show, for example, bad data. I'm going to go ahead and, for the sake of simplicity, just get rid of the new stuff I got in here. Let's say that I'm going to go ahead and try and put in 4.7 for Bill. So let's go ahead and run this and see what happens. And here it says GPA out of range, re-enter between 0 and 1. And it put the default in there on there. So we're getting some kind of feedback. It's a little crude, but this is just meant to give you like a little orientation to this. We could spend a little bit more time formatting this. And of course, we could spend a little bit more time, for example, mutating and things of that nature, so this was 3.7, right? Let's go ahead and put that back. But let's say that, we go ahead and mutate, let's go ahead and do, let's mutate the GPA, right? His GPA on here. And, the way we do that is we're going to go ahead and do S1 dot set GPA. Okay, and I'm going to go ahead and pass it. Let's just pass it 3.0, right? And then what I'm going to do here is I'm going to do an S out, and then I'm going to go ahead and just show you the data again. And you should expect to see that was updated after the mutation. Okay, so here we got the data down here below. We've got Bill 3.7, 55, and Bill, I probably should have updated the hours to simulate this a little bit more, to show you, simulate the idea that the GPA dropped after taking some other courses, didn't do so good. But basically, you've got the idea here. This is how we use a setter, right? In distinction to a getter. So a getter is a return statement, and a setter, okay, is an assignment statement. Okay, so that's how you do OP stuff. Now, it's not exactly clear to some students how you go ahead and create your files. And let me go ahead and show you how you can go ahead and do that real fast. Let me go ahead and I'm not going to build the whole thing for you, but let me just get you going. I'm going to go ahead and just close this. Let's say I want to build an employee one based upon an employee class. So I'm going to go ahead here and go to File, New Project, Java Application, Next, and I'm going to just call this Employee Client. Okay, I'm going to put it on the desktop, and I'm going to go ahead and leave the package statement in there. Finish. Okay, so before I go ahead and do anything here in main, and I'm not going to get rid of all the stuff that I usually get rid of, I got to create the non-application class, right? So basically, I'm going to come over here to File, New File, not New Project. I'm going to choose a Java class next, and I'm going to call it Employee. Okay? Pressing Enter. Notice how it's in the package Employee Client, right? That's very important. And then we're going to go ahead and build it. So how do you want to define this? You can go ahead and say something, like private name. It's pretty much the same idea, right? Private, the name would be a string. I was doing another programming language where it's not required. Private, and then let's go ahead. What do employees have? They have a department number, right? So let's just make that an integer, right? And then let's go ahead and do salary, right? That would be a double. Right? So then you would have to go ahead and create a constructor, and remember the constructor is the same name as the class. And if you ever I recommend that what you could do is when you're building your stuff, you need to go ahead and go back and look at an example. You can just go back to your book, and this is a great example that she's got here for almost any beginner, concept on here. So let me go back to where it was student, right? Right. And any example, she's got like, here's one that she's got here. And in this particular one, see this, you got to be able to distinguish, this is the application class. And she's going to go, this is the application class, and she has to build, this is the main, and she has to build the other one on here. So you got to build the constructor, and she, walks you through that. So the book is full of lots of little, examples on here. Some of them are based on, say, for example, Alice, so a lot of times my students, they just don't want to go ahead and open up an example. Like here's an example of a constructor. Remember I said that the constructor is the same name as the class. So you say public, right, has no return type, and then you've got to go ahead and put in, those, the different things that we want to go ahead and do. And then we're going to create setter and getter methods on here. Okay, so this would be, this inside of the class. I like to go ahead and align so we'll go ahead and say public on here. I don't know why that's coming out, right? All right, so public, and we're going to call it employee, right? And then we're going to bring in, and she likes to put in the word new in here, so that would be string, it would be new name, and then we got in for department number, new department num, and the salary then would be a double new salary. Okay, you have to have your opening and closing curly brackets. And this is not going to be complete until we go ahead and do our setter and getter methods. So you're going to go ahead and have a setter and a getter method for each one of these. Again, how do you do this? I would recommend go back to the book and look at the examples. Like here's an example of a setter. So you're going to have like a get name and a set name. So a setter is going to be an assignment statement. Okay, so let's come back over here, and we'll go ahead and just continue to build it like that. All right. So you will instantiate your objects inside of main. All right. So I'll let the rest of the building to you. You could, once you went through the student example, it's pretty much the same idea to create an employee. Just look at the student example and finish building this as your little, kind of little challenge, to end my little demonstration for today. But other than that, that's all I have for you today. Thank you very much. Goodbye.